We are the Entreprep group, and our project is titled NBA Game Predictions. The goal of our project is to predict the outcome of an NBA game using player statistics. Why is this project important? Basketball is the 7th most popular sport in the world and 2nd most popular sport in the United States with millions of followers and players. Predicting the outcome of a game can help organizations and staff improve their teams and strategies, can help current basketball players improve their gameplay, can help interested basketball viewers understand the games they watch, and can help legal bettors make optimal decisions with their funds. About the data. For our train test split, we did a 60-20-20 split after randomly shuffling, and we had no stratification. For outliers and issues with our data, we dropped the 3 points made column due to errors in the original data set, and we did not remove outliers. They were not a major impact.
So for exploratory analysis, the first thing we started out by doing was looking at points, because at the end of the day, points are the most important statistic, because the more points you get, you win the game. So we decided to make side-by-side box plots of points scored by players in the games that they lost versus games won. We expected to see a distribution that was shifted higher for games that were won. However, we noticed that both the box plots had the same exact quartile 1, 3, median, and almost the same maximum. However, there were a few outliers for games that were won, which makes sense. So the next thing we wanted to look at was how do all the independent variables, or our main stats, we like to call it, how did they correlate with each other as well as the outcome of the game. So this correlation heat map shows all the selected statistics that we found that we thought were most important to a game, things like assists, steals, rebounds, etc. And we noticed that all the selected features have very low correlation with the target variable result of team one. Blocked shots, interestingly, had the highest correlation with the result of the game. However, this was still only 0.072. Another interesting thing to point out is that minutes has a high correlation with the other feature variables. For example, minutes and points have a 0.8 correlation, which is pretty high. This also makes sense logically because the longer you're in a game, the more points you tend to score. Similarly, minutes and assists, minutes and steals, so on.
So then we worked on the confirmatory analysis. So for this, we wanted to predict the game's outcome using our data. So we created a logistic regression model because we wanted to examine the relationship between our numeric independent variables and a binary dependent variable. In this case, it was just whether the current player's team won or lost. We scaled the features beforehand to remove errors, and then we performed a little bit of hyperparameter optimization. Yeah, so in the end, our model had an accuracy of 0.55, which is higher than our baseline model, which is a majority classifier that just has an accuracy of 0.5, just by predicting either just all wins or all losses. The rate of predictions versus true values is shown in the confusion matrix. And our model tended to predict victories regardless of whether the team in question had actually won or not. Although it did predict victories more often with winning teams, which is good.
So conclusions, we learned that outcomes of a basketball game are difficult to predict. There are many non-recordable factors that can potentially affect the outcome of a basketball game. For example, a player could be having an off game or coaching decisions that could change the flow of a game. Furthermore, simplistic classification like logistic regression may not be the best to fully capture the complexity of a basketball game. Some limitations and assumptions our model has are that it assumes game outcome can be predicted by a single player's performance. However, there are 8 to 10 different players on a team and they're all playing together to win. The model looks at random games in a season rather than looking at them as a time series. So it does not take into account possible player fatigue or injuries that could affect performance. The next steps we should take would be to test out more complex models to see if they are a better fit for our predictions and to look at all the games in a given season as a time series.
Thank you.